Okay, this is a 2013 mid-year exam paper, MCQ questions. Okay, first question, a gas X is less dense than air, very soluble in water, and is an alkali. So which method is used to collect a dry sample of the gas? Now, it is an alkali, meaning that if you collect the gas by passing it through a sulfuric acid, there will be reaction. There will be acid-base reaction. So this method cannot, because the gas will react with the sulfuric acid. It is the fact that it is less dense than air, meaning that it must be collected using upward displacement, upward delivery method. This is upward delivery. Downward delivery is for collecting gases that is denser than air. And then the fact that it is very soluble in water, meaning that you cannot pass through the gas, you cannot pass the gas through the water, cannot pass the gas into the water, otherwise it will dissolve in the water and then nothing will be collected here. So this method also cannot. So the answer is A. Okay, number 2, which changes occur when a liquid at 50 degrees Celsius becomes a gas at 120 degrees Celsius? 50 to 100. So at 50 degrees Celsius, when it is a liquid, what happened to the particles? They are actually not closely packed. Then after that become a gas, which means that they are very far apart. So the separation of particle will increase. How about the energy of the particles? At liquid, not very energetic. At gas, is more energetic. So energy of particle actually increases. Okay, so the answer is C for 22. 23. Potassium nitrate crystals can be separated from sand by using the processes shown below. What is the correct order for the processes? Now, you need to know that from the solubility table, all nitrates are soluble. Okay, so when a potassium nitrate is soluble and then sand, you know that it is not soluble. So therefore, the first way to separate them is to dissolve them in the water first. Alright, dissolve it in the water. Then after that, you should filter them to separate the solution, the potassium nitrate solution and the sand. Then after that, whatever solution that you get would be the potassium nitrate solution. Then you evaporate and then you crystallize it. Okay, so 23, the answer is D. Okay, so you need to remember from your solubility table, all nitrates are soluble. Anyway, potassium is a group 1 metal. So group 1 salt, all of them are soluble as well. So potassium nitrate is soluble. Okay, 24. The table below shows the number of protons, neutrons and electrons of two ions X and Y. Which one of the following is correct? Now, different element and same element. Different element means the number of protons are different. Same element means the number of protons are the same. Okay? If two substances, they have the same number of protons, meaning that they are of the same element. So in this case, the number of protons are different. So they must be different element. So C and D are incorrect. Now let's look at positive and negative ion. Positive ion is when number of protons is more than the number of electrons. Negative ion would be the other way around. The number of electrons is more than the number of protons. So in this case, in both ions X and Y, number of protons is more than the number of electrons. Therefore, they should be positive ions. Number 25, an element X forms a basic oxide formula X2O3. In which group of the periodic table is X likely to be found? Now, what is the meaning of basic oxide? Basic oxide, this is from the acid-bases chapter. Basic oxide means that all of them are actually, basic oxide are basically the metal oxide. I'm trying to find out the notes the mind map that shows you the different types of oxide. Where are they? And I think I found them, and they are all here. This is acid bases chapter. Okay, the types of oxide, acidic oxide and basic oxide. So basic oxide are basically metal and oxygen combined together. They are called basic oxide. So from here you can see that X, it must be a metal, so it's either group 2 or group 3. Okay, from the formula X2O3, how do you get this? It's actually from X3 minus O2 minus. Okay, by working backward. Okay, if you have two ions, X3 minus and then the O2 minus, if you want to come up with the formula when X and O combine, you have to cross multiply. Correct? You have to cross multiply, and that would give X2O3. Oops, sorry. O2 minus, this one must be X plus, X3 plus. Okay, if you have two substances, X3 plus, O2 minus, if you want to come up with the chemical formula of the compound form when X and Y combine, you have to cross multiply, and that would be the result. So you just make use of the chemical formula X2O3 and work backward. You should be able to get X3 plus and O2 minus. Therefore, X form an ion of charge 3 plus, so this X must be from group 3. Okay, so for number 25, the answer is B. Okay, another example would be, for example, you have a calcium and oxygen. You're going to come up with the formula, the chemical formula of calcium oxide. What do? You have to write the ion, the calcium ion formula, which is Ca2 plus, oxygen formula, the oxide ion formula. Okay, O2 minus, and then you cross multiply, and then you get Ca2O3. You simplify it, becomes CaO. Okay, so by working backward, you'll be able to come up with the ions, the formula of the ions. Okay, 26. Element X has an electronic structure of 2881. So X must be in group 1. Element Y has an electronic structure of 286. What compound is formed when X and Y react? So X, since it is from group 1, it will form ion of X plus. Y, since it is in group 6, it will form ion of Y2 minus. When you cross multiply, you get X2Y. Okay, X2Y. So which one? Is it covalent or ionic compound? Group 1, it must be a metal. Group 6, it must be a non-metal. So metal, non-metal, ionic compound. So the answer is C. C. Okay, 27. In which one of the following sets do all the compounds contain only ionic bonds? So ionic bonds must be metal and non-metal. Let's go from here. Calcium oxide. Calcium is a metal. Oxygen is a non-metal. Carbon and oxygen. Carbon and oxygen both are non-metal. So it is covalent. So A is out. How about B? Calcium, oxygen, yes. Magnesium, oxygen, metal and non-metal, yes. Sodium and chloride, metal and non-metal. So all of them are metal and non-metal. So all of them are ionic bonds. So the answer is B. Okay, 28. The diagram below shows the pH ranges of 3 indicators X, Y, and Z. The 3 indicators are mixed together in a beaker. What is the possible value such that a mixture of this indicator will only produce yellow color? Now, if you look at it, yellow, this part will be colorless. This one is yellow. So yellow plus something that is colorless plus something that is yellow will give you yellow. So only this part, okay, only this part will produce a mixture that will produce yellow color with the indicator, because yellow, colorless yellow will give you yellow. So only when X, Y, and Z are within this pH ranges, which is from 6 to around 8.5. So 6 to around 8.5, 8. So 28, the answer is C. Okay, so when X, Y, and Z are all of pH 8, then the mixture of the indicators would be yellow. Okay, 29. Element L burns in air, giving a product that dissolves in water, producing an alkaline solution. So this L burns in air. When something burns in air, it must combine with the oxygen in the air to give you a product that dissolves in the water. That means this product must be soluble. And soluble already will give you an alkaline solution. Okay, soluble, and then it will give you an alkaline solution. Alkaline solution, that means it must be something hydroxide. So something that burns in the oxygen. When carbon burns in the oxygen, okay, let's say we look at air, carbon burns in the oxygen, what do you get? Carbon dioxide. Is carbon dioxide soluble? When carbon dioxide is dissolved in water, carbon dioxide is actually slightly soluble in water. You get something called carbonic acid. Okay, and carbonic acid is actually acidic. Anyway, carbon dioxide is a non-metal oxide. Non-metal oxide, okay, from the types of oxide again. Non-metal oxide is actually an acidic oxide. So carbon dioxide, when it dissolves in water, it will form, carbon dioxide is actually an acidic oxide. When it dissolves in the water, it will become carbonic acid, okay, which is an acid. It is not an alkaline. How about when iron burn in the air, will become iron 2 oxide. Is iron 2 oxide soluble in the water? It is not. Iron 2 oxide are not soluble. How about sodium? Sodium oxide, is it soluble in the water? So from the solubility table, we know that all group 1 compound, all group 1 oxide are soluble. Okay? So from the solubility table, we know that all the group 1 salt are soluble. Okay? All sodium salt are soluble, which means that sodium oxide is soluble. When sodium oxide is soluble in water, sodium oxide being a what? So just now we mentioned that acidic oxide is a basic oxide. Okay? Just now we mentioned that metal oxide is a basic oxide. So sodium oxide is a basic oxide, meaning that when sodium oxide dissolves in water, it will form something that is alkaline. Okay? For example, sodium hydroxide dissolve in water to form sodium hydroxide. So the answer is C. The last option is sulfur. When sulfur burns in the air, it will become sulfur dioxide. Sulfur dioxide is a non-metal oxide. Non-metal oxides are acidic oxide. 29. The answer is C. 30. Ammonia is formed according to the equation. What is the volume of ammonia formed when 100 cm³ of nitrogen reacts with an excess of hydrogen? When you see excess of hydrogen, that means you don't have to look at hydrogen. You have nitrogen, and then you have to find out the volume of ammonia. Okay? What is the mole ratio? 1 mole, according to the equation, 1 mole and 2 mole. Now you need to know that for gaseous products, when the reactants or the products or when the substances are in gaseous form, mole ratio is the same as the volume ratio. Okay? For gases, this part I've mentioned it many times. For gases, mole ratio equals to volume ratio. So mole ratio is 1 mole is to 2 mole. How about the volume? 100 cm³ of nitrogen. 100 cm³. 1 mole is to 2 mole. 100 cm³ would be to 200 cm³, because mole ratio is the same as the volume ratio. So the answer is C. 30. The answer is C. Okay, this is only true for gases. Anyway, they are all gases here. 31. After adding dilute hydrochloric acid to a solid sample X, effervescence occurs. Okay, HCl plus something, you get a gas. The gas forms a white PPT with lime water. That means this gas must be CO2. On adding a sodium hydroxide solution to a different portion of a solution of X, a white PPT is formed. Okay, then after that, this X plus NaOH, you get a white PPT. And this white PPT dissolve in excess. Okay, this is a summary of the question. And the question asks you what is X. Now the fact that when X is added to acid, it forms carbon dioxide. Only one substance can this X be. It must be a carbonate. Okay, so zinc sulfate is wrong. It's out. Then after that, add sodium hydroxide. So sodium hydroxide, you need to realize that, you need to be able to recognize that sodium hydroxide, NaOH, is commonly used to, is a reagent that is commonly used to identify the positive ion. Okay, at NaOH you get white PPT dissolve in excess. So you have to refer to your QA. Add sodium hydroxide, you get white PPT dissolve in excess, which is soluble in excess. So it can only be aluminium, lead-2, and zinc. The negative ion we know that is carbonate. Now it's the positive ion. So the positive ion must be one of these three. So it could be on adding sodium hydroxide to a different portion of solution X, a white PPT is formed. This precipitate dissolve in excess sodium hydroxide. What is X? Soluble in excess. So it can be zinc, it can be lead-2. So it's either A or C.